My name is Justus Heekin, and this is BlackjackNET. I created two blackjack playing neural networks and will compare their strategy to the solved strategy. First, let's look at the simplified blackjack rule set that we'll be using. The player is dealt two cards, and the dealer is dealt one card face up. The player can hit and draw another card, or stand. If the total of the player's cards goes over 21, he loses immediately. Once the player stands, the dealer must hit until his total is 17 or greater. If the dealer busts, he loses, and if the player has not already busted, then the player will win. Otherwise, whoever has the highest total will win the hand. The value of a 10, Jack, Queen, or King are all equal to 10, making 10 the most likely value to draw. I trained the first network on a database of blackjack hands that were played randomly. The target variable is the correct action in that random hand. For example, if the random player chose to hit and wins the hand, then hit is the correct action. The output of the network is the probability that hitting is the correct action, which is a binary classification. As a result, I used a sigmoid activation and binary cross entropy for the loss function. The second neural network uses Q-learning to choose the best action. Q-learning is a form of reinforcement learning, where the algorithm calculates a Q value for each action in each state, which is the expected value or reward of that action. Q-learning is able to use future rewards in its calculation. For example, the reward of hitting in a certain state takes into account the potential of hitting in a future state. The probability of a win or tie is shown for a given player total for each strategy. The logistic regression network and perfect strategy clearly outperform the others for the higher player totals. We can calculate the return to player, or RTP, of each strategy as the percent of the initial bet we expect to get back. So if we bet $100 and on average get $95 in return, the RTP is 95%. These are the strategies each network is using, and the perfect strategy. Intuitively, it looks like the Q-learning network is playing closer to the perfect strategy than the logistic regression network. However, the magnitude of its mistakes are much larger. Hitting on an 18 through 20 is a disaster for the expected value, as the chance the player will bust is very large. The logistic regression tends to make more mistakes, but they are smaller in loss of expected value. The Q-learning network only trained by playing a few thousand hands of blackjack. In the future, I would like to improve this network by training on tens of thousands of hands. I expect the network will learn to be more conservative at higher player totals and gain a much larger RTP.